Today we are going to be comparing linear relationships. So we're on page 94 through 98 in our orange books. And problem 1 says George had $20 and was saving $15 every week. On the graph it says Mark also started with $20. His savings are shown on the graph below. So we need to compare George and Mark because the question says who will have $100 first, George or Mark? In order to compare them, the easiest way to do that is to put both George and Mark on the graph, and then we can see very easily who's going to have $100 first. So Mark is already on the graph. He started at $20, and you can see after 1 week he had $30. After 2 weeks he had $40, and after 3 weeks he had $50. Now let's put George on the graph. So George had $20 to start with, so he started at the same place as Mark. We'll put a dot on the $20, and he was saving $15 every week. So after 1 week, he would have had $35. After 2 weeks, we add another 15, so 35 plus 15 is 50. And that's the top of our graph. So now we can draw this second line, and this second line is George. The first line is Mark. So we can easily now see that George is going to have $100 first because his line is higher than Mark's. He's going up at a faster rate. Every week, George saved $15, but based on our graph, Mark is only saving $10 a week. So George will have $100 first. And then let's look at number 2. So we're still on page 94 in the orange book. Okay, we have to put the cyclists in order from slowest to fastest. And we have cyclist A, B, and C. Again, we want to compare, and cyclist D, sorry about that. We want to compare who's going fastest, who's going slowest. So the easiest way is to put all 4 cyclists in one graph, or they can all be in tables, or they can all be in equations. We want them all in the same form so that we can compare them more easily. So cyclist A right now is in a table, and we know that we can find his speed or his slope from the table. So to find slope from the table, we find the difference between 1 and 2 is going to be a positive 1 on the y-axis, and the difference between 2 and 4 is going to be a positive 2 on the x-axis. So our slope is always y over x, and we have 1 over 2. Okay, so the slope for cyclist A is 1/2. Okay, then on cyclist B, we know that Bob cycled 12 meters in 6 seconds. Okay, so I'm going to put that in a table, just like cyclist A. So here's x and here's y. In 6 seconds, and we know time is x, he went 12 meters, and that's our distance. So if he goes 12 meters in 6 seconds, in 3 seconds, he would go half of that, which is 6 meters. Okay, so now we can find slope using our table again. The difference between 12 and 6 is minus 6 on the y-axis, and the difference between 6 and 3 is minus 3 on the x-axis. Now we can put that into our slope y over x, which is negative 6 over negative 3, and negative 6 divided by negative 3 is positive 2. Okay, so our slope, or our speed, for cyclist B is 2. On cyclist C, we already have the slope because it's in an equation. So slope is always right next to the x, and we know our slope on cyclist C is 1/3. And then we want to find the slope, or the rate of change, the unit rate, on cyclist D using our graph. So remember, we do that by drawing a triangle. We put 2 dots on intersection points, and we can connect our triangle So we have 2 on the y-axis and 3 over on the x-axis. And so now that we have all of these in a form that is the same, we all have the slope or their rate of change, we can easily put them in order from slowest to fastest. So the slowest person is going to have the lowest slope. And the lowest slope here is cyclist C, 1/3. That's our lowest number. Then our next lowest number is cyclist A at 1/2. And then cyclist D at 2/3. And the fastest cyclist is cyclist B because his rate of change is 2. Okay, so when you're comparing information, just make sure you always put it in the same form. You can graph them all, you can put them all in a table and find slope, you can write out an equation, but in order to compare, we just need to have them all in the same form.